I've got the cross slide here on the mill table. I've got it on this big, I think 12-inch angle plate with a couple of studs going through there to clamp it through the center. And we indicated off of this face that we milled, and then this face which was scraped. It's the bottom. So we are within about a 1/2 thousandth of being perfectly true, which is way good enough for what we're doing. But we've completed all the work on the lathe itself to get ready, essentially, to install the DRO. So that's pretty exciting. Came out just fine. These are 4.5 inches on center. So the next thing to do will be to drill a clearance hole and countersink on our mounting bar and reassemble the lathe. We can do it in either order. This is my first time trying a new cutting fluid. This is Rapid Tap. So my big gripe with cutting fluids is usually the smell. I've got a pretty sensitive nose apparently, and so real smelly tap fluids or cutting fluids tend to give me a headache. So I try to find something that doesn't have too strong of a smell and doesn't smoke up the place because, you know, I'm always working with the doors closed and the air conditioner on. So for work holding, we've obviously got the piece in the vise, but in order to not have to move the part around or put screw jacks underneath the overhanging end, which can lead to some problems of its own, I have come up with a little something here. These are my Moore tool blocks, and I was just kind of fumbling my way through it, so I didn't record. But this is works out to be a perfect solution. So the bed of the vise is 2 7/8 from the table, and these Moore blocks come in 1, 2, 3, and then these are 1.5 by 1 1/4 by 7/8. So 7/8 plus 2 gives me the bed height of the vise. So by screwing these guys together and then putting another 1, 2, 3 block on the back, I've been able to essentially give myself a longer vise without the clamping part. So that gives me an opportunity to just use a can't twist clamp to keep that secured to the back fence, if you will. And the other thing I'll probably do is make some T-nuts with 1/4 20 holes in them, and then I can screw the blocks down directly into those T-nuts, and I don't have to have the toe clamps involved. So we'll see how much I like it. I may I'd like to invest in a second vise, but that's a big old hunk of money to get a nice quality vise. So this is a pretty good substitute for the time being. So instead of using a counterboring tool, I'm gonna just use a 5/8 inch end mill. There we go. Now that the part's out of the way, you can kind of see my setup blocks. Now we need to make a cover for the scale that will mount onto that bar. Ooh, don't tell my wife. Got the ends of this thing cleaned up here on the mill, and then milled the other end down to length. And I think what we're gonna do is use our setup again to reduce this leg. This is a 2" by 1.5 inches, and what I really need is 1.5 inches by about 1.75 inches. I think what I'll do is put parallels underneath it just to raise that up just a touch. Parallels down like that is what I meant. Okay, that should be plenty, but still close to the supports here. And then obviously just clamping on up against this isn't super effective. So what I've got here is just a big long piece of aluminum bar stock. And if I take that and have it up about level with the top of the jaws, I can crank down on that, and the bottom of the part stays fairly flat, but it really pushes into the back jaw of the vise. So that should be okay, and then I will put a can't twist clamp down here. Definitely bouncing around, isn't it? Don't like how much vibration was going there, so let's try this. I don't know how much room I'm gonna have. It's gotta be better, but I don't know how much better it'll be. It's just clamped onto the bottom of the piece of angle iron instead of on here, which is where I wanted it, so this dampening effect was greater, but let's give it another pass and see how it does. I found a little bit better speed and feed combo. Made it a little quieter and ran a little smoother. I realized after using it for a few minutes what would have been better is to have one setup on either side. So that's what I changed it to real quick. Just took a couple of minutes. What we need to do is just machine this nice and parallel to the outside. Actually took the part out of the machine and decided I wanted to go ahead and put a chamfer on it. Yeah, I'll probably have to do it in more than one pass, which is okay. I think we're ready to go on to the next step. So what we need to do is make a hole and then countersink it for our number 10 screws. Did a little bit of layout here just to keep track of what we're doing and make sure we don't make a huge mess and have to start over on this. I do want this to be strong enough that any workpiece I drop in the lathe or tool or whatever else has no possibility for damaging the scale. I just want it to be 100% bulletproof. This isn't going to dent easily. It's not going to bend. So that's the rationale here. It's totally overkill, and just a bent piece of sheet metal would probably be fine forever, but that's not really how I do things. So we need to support this somehow. I think what we'll do is clamp this guy in like we have been, and then on either end, I think it should be enough to put the cant twist on and clamp it to the 1, 2, 3 block. Some more rapid tap. Obviously I could put an indicator on here just to see how much it's moving, but I couldn't really feel any movement. This is something that I didn't really get the first couple of times I saw someone do it. So what I want to do is kind of give detailed instructions on how I make consistent countersinks across a piece of material when I want them to all be the same size and everything. Like most things machining, you can do it in any number of different ways, but this seems to be the easiest for me. So I'm going to take my little removable quill stop thing. You can get these on eBay or metalworking supplier place for pretty cheap. So I'm just going to give myself a stopping point there. So that is my dead stop, and I'm just going to zero the Quill DRO just to give me another point of reference, and then lock the quill. So now this guy is down as far as it can go without taking that off. What that leaves us with is a gap of, finger and a half there. So when I turn the spindle on, what I'm going to do is raise the knee up so that it hits the countersink, and then lower it back down, and then back and forth until I get it right where I want it. And then at that point, I can lock or just leave the knee where it is and loosen the quill lock. And so when I go over to my next one, I can just bring the quill down to my stop that I just set. Okay, so we move the knee up to the part, or up to the cutter. Okay, I started making chips. There we go. So now that's a really good spot, nice and flush. So if we take this guy out, we can raise the knee back up to the spot where we stopped. So there we go. The countersink is nice in its spot where the maximum depth we drilled. We can come up here and release the Quill lock, and that gives us room to move the table and not hit the work. And then when we come down to the next one, we just go until we hit our stop. And then all 5 of these countersinks will be exactly the same. If I did this right, should be able just to cut this until I run out of room. There we go. Looks pretty much identical to the first one. The end of our bar here is going to look about like that. This is my Fireball tool shop blocks set. Has a 3/16 inch block in it. So the holes are going to be centered on the scale mounting bar. So I'm not going to worry too much about getting that perfect by eye on this. What I'm really looking for is the position along the length. And again, this is just to double check and make sure we're in the spot we think we're in. That's about what it's going to be like. So we'll just mark these with our marker. And if we're off by 1/2 inch or something, we'll know that something's wrong. So the tap we're going to use this time is a coated Osg Tap. Trying to get that in focus for you. But this is a titanium carbonitrided coated tap Ticken. And it's an H3 fit. This is a tap for tougher materials, which this is. This isn't, you know, it's not like Rockwell 63 or anything like that, but it is pre-hardened and tough stuff, if nothing else. So this is a powdered metal tap as opposed to just regular high-speed steel. I didn't think carbide was necessary at all, especially for that much greater expense involved. And because this is tougher material, we're going to go with the tough material fluid, Molly Stinky D. Okay, I'm watching my depth, and I've got my hand on the power button, power switch. So far, so good. Okay, went a little bit deep beyond my 5/8 of an inch, but that's perfect. Just want to avoid going full depth and breaking something. Let's test our fit. Perfecto. So that was an excellent result. Time to fess up and be honest with you guys, because that's what I like to do. This is the second time I've made this part, and the first time ended in tragedy. The last hole, I actually had 6 holes on that one, and the last one, I broke the tap. So why did I not put in more effort to remove the broken tap and reuse this piece? Well, this piece was already kind of an experiment. It's not the right size material for what I wanted, but it's something I had on hand. And my plan was, you know, let's see if it works out well and I get all my, you know, work done on it, and maybe we can just make it good enough and it'll be fine. So that usually doesn't work out well because I'm such a, because I'm so neurotic. I want to change it and make it perfect, or make it as perfect as I can anyway. But so it's actually okay that this got scrapped. It helped me learn something and wasn't a big deal. The new part, I don't have a whole lot of time into it. and it's going to end up just right. So what did I do wrong that caused that broken tap? Well, there's a couple of things, and the primary problem was using the wrong tap. I had a high-speed steel number 10 tap, 1032, and I just went ahead and used it, and it worked fine for 5 holes, and then the 6th hole it snapped. My major problem was the tap. It was uncoated and not meant for hardened material. The other thing was I was trying to cut too much percent of threads. It's kind of a clumsy way to say it, but basically I was going for full 74% threads instead of using a larger tap drill, which would give me a little bit easier time. There we have it, using the right tapping fluid, the right tap, and drilling the proper hole makes all the difference, of course, in tapping. And in this case, still looks like I have a brand new tap. So I'll get this cleaned up and get all of this black Moly off of everything. And then we can go mount this guy on the machine and see how the cover fits. There we go. That sucker is tough. So we've got about 1/8 of an inch clearance on the bottom here, so that chips, or if I have a scale laying there or something like that, it's not gonna immediately damage something. That's the idea anyway. But yeah, that thing is solid. This angle iron is 3/16 inch thick, so it's not super heavy, but I think plenty heavy enough to prevent any workpiece falling out of the chuck and banging on here. This is not gonna be able to dent enough to hurt anything, and busting out all of those screws all at once would take a tremendous impact. I am feeling pretty good. We're getting there. I know this has been a slow project and taken a very long time, but it's just how it goes sometimes. I've got limited time and energy, and I want to do it a certain way, so those factors together mean this is a slow one.